Hi everyone! In this video I'll be discussing scatter graphs, which is the content that you need to complete exercise 5 of your statistics work. So scatter graphs, according to the definition in your book, is a way of presenting data that has two variables and a probable relationship. Now in simple English that means we have two variables, for example x and y, or soccer balls and netballs, whatever you want, and we're trying to see if there's any relationship between these two variables. And so what we do is we put them into a table against each other so we have their values, and then we try and plot a scatter graph with them. So as an example, I'm going to be using the example of an ice cream shop. That's why I have a terribly drawn ice cream cone there. So say we have an ice cream shop and they record the temperatures and the number of ice creams that they sell. So for example, on a day when it's 0 degrees Celsius, they only sell one ice cream because it's quite cold. But then on a day where it's 30 degrees Celsius, they sell up to 10 ice creams. Okay, so what we do is we start by plotting all these values as points on a graph as follows. Okay, so if we take the 0 degrees and we sell one ice cream, then we plot a point somewhere around here. Okay, let me just make that a little bit bigger so we can see it. If we have then, when it's 10 degrees Celsius, we sell 3 ice creams, so that's a little bit more. When it's 20 degrees, we sell 6 ice creams, again, quite a bit more. And when it's 30 degrees, we sell 10 ice creams. Okay, obviously you're going to have points and you're going to draw it to scale, but this is how we go about doing it. Okay, so what can this graph actually tell us? Well, the first thing that it can tell us is the relationship between ice cream sales and temperature. So in this case, we can see that there's a sort of a line like that, okay? And what this line shows us is that there's a positive relationship between temperature and ice cream. So as the temperature of every day goes up, the number of ice cream sales increases. So basically, the ice cream shop owner would know, okay, when it's 30 degrees Celsius, we need to have more ice creams in stock because we're likely going to sell more. But obviously, when it's 0 degrees Celsius, it's freezing cold, middle of winter, we don't need as much stock because there's probably not going to be that many sales. So we call this type of positive relationship a positive correlation. There are many different types of correlations, and I'm going to go through a few examples now with you so we can get the hang of what type of relationships we get with our data. Okay, so as I said before, correlation is the relationship between the two variables. So there are 3 different types of correlation. The first one you can get is when there's no correlation, there's no relationship. So that's when you get the type of graph that we see in that first example there, where there's just spots all over the place and you can't really see any relationship. That could be positive, could be negative, could be flat, we would never know. There's no relation, so we say it's no correlation. And that's the example of, depending on how many soccer videos you watch, it doesn't have any effect on how many goals you score, which is why there's no relation. For the next example, we look at the number of hours you spend studying, and now like that's actually studying, not like studying to tell your mom that, but then you're actually on Instagram, because I've done that, but proper studying, and then how it affects your mark for the test. So we say that's a positive relationship or positive correlation. That's because as you increase the number of times you spend studying, your mark will hopefully also increase. Okay, so we call that a positive correlation. Now for this example, I also just need to point out, in some cases you get really lucky and your points actually start to look like that. They're in a straight line, basically. Okay, that's called perfect correlation. Okay, perfect positive correlation. Okay, in the next example, we have how old a chicken is versus the number of eggs laid. Now please don't fact check me on this, I'm not exactly a farmer, but we assume that as the chicken gets older, it's going to lay less and less eggs, okay? So if we draw a line through that sort of data, we get a line like that, and that's called negative correlation, okay? So again, it's a negative relationship, negative correlation. The same thing, if we get a line and it's a really perfect straight line like that, that would be perfect negative. Okay, so those are your 3 types of correlation. That's what you're going to use every time. The final section of work that we need to work on for scatter graphs is known as the best fitting line. Okay, so this best fitting line is basically what I was drawing before. It's a line that shows the general relationship between the points that you've plotted. Okay, so you have to try and make sure that this line passes through the points in such a way that, like, you usually want to try and get equal points on either side of the line, or you want to at least get it to pass through the mean or the median of the points. So I'm going to do an example with this using the case of the ice cream from before, so we can see how we draw the line of best fit. Okay, so looking at the ice cream example from before, we can draw a line just sort of like I drew earlier, where we just try and get the points sort of in place and make a line. So let's say something like that. That line is good enough in the sense that it shows us it's a positive correlation, and that's basically what we want to know. But if the ice cream manager were to make predictions based on this line, for example, if he used the line and he drew it further up and he said, well, what happens if the temperature gets to 35 degrees? How many ice creams would I need in stock then? Then you would want it a little bit more accurate, which is why we want to try and make it pass through the mean or the median. So in this example, I'm going to make the line pass through the mean. So because we have two sets of data, well, we have two variables. We've got the temperature and the ice cream. We need to calculate the mean for both of them. Okay, so to calculate the mean, we know that we always use the same. Mean is the sum over the number. Okay, so we use that for both. So for the temperature, the mean is going to be 0 plus 10, so that's 10, plus 20 is 30, plus 30 is 60, over 4. And for the sales, we're going to do the same thing, sum over number, and we're going to get 1 plus 3 is 4, plus 6 is 10, so we're going to have 20 over 4. Okay, so that gives us 15. And that gives us 5. Okay, and basically this is our x point, that's our y point in this case. So we can just put it into our mean point. So we've got 15 and 5. And then what we do is we plot that point on our graph so that we can draw a more accurate line. So we've got 15 and 5. So somewhere around there. And then we just draw our graph again as before, just making sure that it passes through that line. Okay, that's the way that we draw a best fitting line in a way that is sort of accurate, so that at least we can make some predictions from it, because that's what's really useful about scatter graphs, is that you can use it to make predictions. So the ice cream manager could now say, okay, well, when it's 35 degrees, this is how many ice creams I need in stock. So that's it on scatter graphs. If you have any questions, please let me know in the comments or on Teams directly or email. You know where to find me. Good luck and keep up the hard work.